So welcome everyone. This is actually our final installment of our deep dive series for Dagster. In this presentation, Tim is going to be talking about data mesh, what it is, and how it can be enabled through Dagster. Just as a reminder, this presentation is being recorded and we'll upload it to our YouTube channel shortly after the presentation. If you have any questions, you're welcome to ask them in the Q&A section of Zoom or in the chat, or you could wait till the end of the presentation where we'll have a designated Q&A time. But yeah, this is going to be an exciting one. So without further ado, let's hand it off to Tim.
Cool. Thank you, Colton, for the intro. And hello, and welcome to today's Dagster Deep Dive. As Colton mentioned, these are sessions where we sit down and talk about our favorite Dagster features and how we like using them. Today, we'll be talking about what a data mesh is and how you can use Dagster as a foundation for enabling the technical side of the data mesh paradigm, while also fostering the organizational portions a little bit too. All right. So across many data organizations, data leaders typically have to choose where on the spectrum of centralization and decentralization they want their teams to be. And it's very easy to accidentally slip in either direction very aggressively and find yourself on the extremes, such as a fully centralized data team where the data function sits separately on their own and their stakeholders submit requests. This structure lends itself to some benefits, like being able to have a strict bar for quality and standards for making data, but it is also typically slower to turn out results because they aren't completely familiar with the business domain that they're working with because they're abstracted and pulled away from it. On the other side of the fence, we have the fully decentralized autonomous data teams. These are organizations where a respective domain gets their own data team, and those data teams have full agency to do what they need to get work done. This is great because no one's stepping on each other's toes and there's much less red tape. But the quality of what gets output is often inconsistent across teams. It's harder for data teams to work together in the situations they do need to. And it's much more difficult for an individual leader to steer this whole ship in a certain direction. And those cons that we just talked about are what a data mesh is proposed to solve for. Now, data mesh is an organizational and technical paradigm for producing high quality data by domain experts. This model allows your teams to be decentralized in execution, but also allowing for defining standards and governance across all of your teams and domains without necessarily being centralized. And there's very little alignment on what data mesh actually is, but what everyone can agree on are these four principles of data mesh, which are having domain-driven data ownership, treating data as a product, owning a self-serve data platform, and having federated computational governance for it. And today we'll talk about how to enable this data mesh paradigm with Dagster. Notably, we'll cover the four principles of data mesh and how Dagster's building blocks fit well with them. We'll paint a picture of what the bounds of what a data mesh could look like, given these four principles, and then we'll see how Dagster's feature set can map over to these principles. But first, let's get started by talking about those core tenets one by one. So in the world of data mesh, the idea of a domain is all about bringing together folks who share the same goals, like grouping into clusters of sales, marketing, or HR. And each group is in charge of creating and handling data that fits their needs, relying on the expertise of folks who really get what's going on in the area. For example, I am still not entirely confident on what happens in Salesforce, but I've helped enough direct-to-consumer e-commerce organizations enough times that I know how to navigate e-commerce as a domain fairly decently. And at the core of this principle is recognizing the importance of having experts in each domain who know their data inside and out. And by giving these folks the reins, organizations encourage a sense of ownership and responsibility over the data that they work with. The next principle is treating data as a product. So in this world of data mesh, every domain is actively engaged in both building and sharing data products. But what exactly is a data product? Well, you can think of it as a high quality export of data accompanied by robust metadata to empower the people that are going to be using it. And data products are stored in persistent storage and are accessible. So these are your files, your tables, your machine learning models, and your streams. And this ensures that they're readily accessible when needed, whether it's for analysis, decision making, or further processing downstream. And the metadata of a data product is so important because it serves as the backbone, providing essential details such as SLAs that ensure that everyone knows when to expect changes or updates to the data, therefore allowing dependent domains know when the data they rely on will be refreshed with new records, or information about when the data, where the data is located, um, or and who is allowed to access it, as that is crucial for ensuring data security and compliance. And by clearly defining access permissions and data ownership, organizations can mitigate the risk of unauthorized access or misuse of sensitive information. For example, there are plenty of times where I've seen people accidentally querying PHI or exporting data in a GDPR compliant setting. And they didn't mean it out of bad will. They just didn't know what they couldn't do with the data, which is why it's important for the people who use your data products to know if they're stepping on any potential landmines and what they can or can't do with this data. Next is identifying who owns and is responsible for the data. This fosters accountability and ensures that there are clear points of contact for any questions or issues related to this data from your downstream users. Then there's this whole aspect of observability and data quality. These insights provide visibility into the health and reliability of the data. If people are using your data, they should know that it's accurate, that it's consistent, that it's trustworthy. And they should also know when your data deviates from those truths. And data products should be accessible by its dependent teams. This means implementing systems and practices that enable data discovery and access, allowing domains to easily figure out what data products they need and which domains those data products come from. In summary, every domain within the data mesh paradigm produces and uses data products. And producing data products comes with responsibility, like embedding metadata such as how frequently the data gets updated, how to access it, and vetting its data quality on behalf of your own users. But making trusted data products is hard. So they might be wondering, well, who defines what it means for a data product to be trusted? And what does trust mean in the first place? Which is why the next pillar is about defining those standards and expectations for data products. Now, federated computational governance is a part that trips up a lot of people. There's a lot of letters, there's a lot of syllables. And to make sense of this one, let's look through each of these words from right to left. We'll start on the far right with the root word governance. This means creating rules or standards on how data is built and shared. Now, it's up to your organization to sit down and think about what requirements you have for the data you're sharing with others. But let's talk about some general topics that you'll have to make decisions about or talk about when it comes to how the data is built. It touches a lot on the points that we were talking about earlier about what metadata a good data product has, such as SLAs. How frequently is the data updated and when is it considered out of date? Or data quality that we've already talked about is important when it comes to building trusted high quality data products. Then other stuff like what are constraints? What are the primary and foreign keys? How does this relate to other data products that are being exported out? As you can see, these are difficult and often ambiguous questions for any data engineer to answer, but very important if you want people to independently build off of your data products. And then comes conversations about how the data should be shared, like who is allowed to have access to this data and how is that maintained? Who is responsible for this data? Who is the point of contact for it? And what's the best way to contact them about the data products? Then what are the expectations for communicating how the schema of this data changes? What happens when a column is added, it's removed, or has its type changed? When people throw around the expression data contract, it could be interpreted as a way to maintain governance over your data products. Now, then the next word is computational, right there in the middle. This means that we can't have everything that we're doing be a manual process. The more this is automated or codified, the less room there is for human error or deviation from these standards. For one, you can automate this with code and configuration and have a lot of the governance be embedded into your data platform, whether it might be in your orchestrator or via CI checks. Doing it in your orchestrator is helpful for things that need to be routinely checked, like data quality. And your CI system can enforce documentation, code quality, and test coverage over it. And the last word is federated. This means that every domain is responsible for ensuring that the data mesh works. A chain, or I don't know, a mesh in this case, is only as strong as its weakest link. Each domain should be independent of each other, but they should all chip in creating and adhering to the computational governance that we've been talking about. This could mean that no single team is responsible for creating the standards. And the way this sometimes plays out is that all domains are responsible for defining the rules collectively. And then you have, let's say, a core data platform team responsible for implementing the computational governance model so that every domain can match the same bar for quality as everyone else with minimal overhead. And then speaking of data platforms, next step is having a self-serve data platform. A data platform is a foundation of shared resources, products, and tools that empower domains to be part of the data mesh. And when we talk about using data products, a strong data platform makes it easy for domains to use data products independently without relying on the producing domains for constant assistance. It's about ensuring smooth access to relevant data and understanding the upstream lineage. And on the flip side, when it comes to producing data products, a robust data platform provides domains with tools and processes for this independent creation. This includes frameworks, libraries, and templates to guide domain teams in producing high-quality data products. Additionally, a strong self-serve data platform enables the programmatic adoption and enforcement of those federated computational governance standards, ensuring consistency and compliance across all those produced data assets. And then this self-serve data platform should be maintained by a data platform team or a group of cross-functional contributors from these domains. They would provide ongoing support, enhancement, and control over governance and provide them to these domain teams. So in summary, a self-serve data platform empowers teams to access and produce data products independently, supported by a robust shared infrastructure and the dedicated efforts of a data platform team. All right, but the thing is, there are many people that disagree with what the structure of a data mesh actually looks like. This is because the right degree of data meshing will vary depending on your organization. It's important to recognize that there's no one-size-fits-all approach to data mesh, but that the ideal setup varies depending on factors like leadership strength, data governance needs, and the availability of resources to empower this. For example, if you have strong data leadership, that can mean less need for a centralized distribution domain. And similarly, organizations with fewer data governance requirements might opt for a more decentralized approach. However, resource constraints, like not having enough software data engineers to staff a proper data platform team, can also influence decisions as to what your structure topology might look like. So finding the right balance in your data mesh setup means considering your organization's unique circumstances and needs. But what holds true across all of these is those 4 principles that we just talked about. But yes, all that being said, 4 principles of data mesh, we just talked about them: domain-driven data ownership, data as a product, federated computational governance, and having a self-serve data platform. And everyone's data mesh looks different, and that is okay. So that being established, let's go ahead and talk about what we're all here for, which is, well, how can Dagster support a data mesh, and how can it enable it? And where does it fit in all this? So if you're not familiar with Dagster, Dagster is a framework for orchestrating data pipelines. You have the flexibility to build pipelines outright or create a platform to enable others to build their own. And as a framework, Dagster is grounded in having strong core building blocks that lets you express whatever you might need when building your data platform or your data pipelines. And I believe that Dagster's framework of building blocks can help enable the technical aspects of data mesh. And just like a slight emphasis on like the technical part of it. I'm not a management consultant. I can't go to your CEO and tell them to restructure your entire organization and tell them that people should work in certain ways with each other. However, what Dagster can do is provide the right functions and levers to you once those decisions have been made and let them express or let you express them in any way that you like. So, whatever your data mesh might look like, you can hopefully implement whatever you need to satisfy requirements with Dagster. However, what we've seen across implementations is a couple common themes, and we'll be talking about those today. Notably, assets and code locations we found are foundational in building a data platform and domains in a data mesh. So let's talk about those two concepts a little bit right now. If you've used Dagster before, you know what an asset is. If you haven't used Dagster yet, that's fine, because an asset is just some data that you produce and save somewhere, like a table, a file, or a machine learning model. You can maybe see where I'm going with this. A Dagster asset can be a data product because it's a piece of data that is defined and stored. But let's talk about some more of the other traits of an asset. Because you focus on defining and chaining assets together in Dagster, as opposed to writing out tasks that just happen to write data, it's easy to see in Dagster's code where an asset is defined and the computations involved with it. You can take advantage of Dagster's full end-to-end lineage to understand how that data product is made and trace back the source data that makes it. If you're a data engineer in domain and you want to better understand how that data product is made, Dagster should hopefully make it easier. And then into Dagster UI, more than just a lineage can be found. In Dagster's asset catalog, you can find all the documentation related to the asset. If we look at the example over here, you can see that we have details like a documented description. When was the last time it was successfully built? How it was computed and where it's stored, and along with some other stuff that we can talk about in a bit. Then the next aspect is code locations. Now, code locations are a part of the core architecture of Dagster. The roots of this go back to the early days of Dagster, and it was made after noticing how brittle deployments were in legacy systems like Airflow. So a code location is a group of assets and other definitions, and they are independent from other code locations. They're separated into their own Python environment and along with their like other Python dependencies. This means that each team can upgrade their Python versions or packages whenever they want. For example, if the marketing team wants to use TensorFlow version 2, but the sales team has a legacy model that keeps them pinned to TensorFlow version 1, that's fine. And will work out of the box without any additional overhead. What's great about code locations is that they can also be deployed separately from each other. And therefore, a broken code location won't break your entire deployment. And despite these separations and barriers, assets can depend on other assets in other code locations. So you can build assets in your domain from the data products in another domain. We just want to iterate on this one. So at a mile high view of everything, this is the basis of setting up a data mesh of Dagster. Each domain can own a code location of their own respective assets, and domains can depend on the data products or assets of other domains. But there's more. Dagster has more features that can help make creating a data mesh even better. Let's walk through the 4 principles of data mesh again, very briefly, and see how Dagster can contribute to the technical aspects of them. So yeah, we talked about it. For domain-driven data ownership, we already established that each domain can get their own code location. These code locations are isolated and lets domains function independently from each other. And like we want data products to be accessible, but only to the right people. For example, Dagster Cloud, you can apply roles and permissions to restrict people from only looking at certain code locations. We also talked about how domains can depend on assets from other code locations. So that's just like what we see here. In this example, the data platform team does some generic modeling, And then the downstream domains of marketing and sales depend on those assets and build their own. We'll look at what those assets look like more granularly in a demo soon, so stay seated for that. Next up is like data products. In addition to code locations, we also briefly talked about how assets can be seen as data products. But there's so much more that can be done about that to ensure that your data products are high quality. For example, metadata can be attached when an asset is defined or when it's materialized. When it's defined, you can embed as much information about it as you'd like, such as the stability of the data product or whether it contains PHI. There are also specific properties that Dagster can take advantage of, such as a dedicated owner's property that will let you say who is responsible for this asset. And as a data producer, you can even send alerts to yourself if any of the assets you own are failing or going out of date, as you can see from this screenshot over here. And the last aspect that will really instill faith and trust when people use your data products is asset checks. Like asset checks are data quality checks that are asserted against an asset. These data quality checks are self-documenting and communicate to dependent domains information about the data, such as the cardinality of certain columns or the nullness of the records. And more importantly, tell both the producers and consumers of the data product when the data is failing these tests. So having good asset checks lets independent domains have faith and make confident assumptions about the quality of your data products. All right. But at the end of the day, each code location can be also treated as just a Python module. Therefore, you can write libraries that share functions, decorators, and utilities that teams can import into their code locations and create a domain that meets the bar for quality that the data platform team desires. If you're using Dagster Cloud, you can use branch deployments to test how changes will impact your data mesh. Branch deployments are sandbox environments that are built with every PR, and every code location can be deployed into the sandbox for testing. And by deploying every code location, you can see how the data products you're modifying can impact the domains that you depend on, such as if another domain breaks, like because of the change that you're making. Dagster Cloud can even tell you what assets are changing in a PR and what assets downstream will be impacted by it. You have detailed control over how you want to find assets that are being changed in a branch deployment, such as like these filters over here. Then finally, when it comes to the federated computational governance, we can reach for some additional features. One of the topics we discussed earlier was keeping up with your SLAs and communicating when your data products are overdue for a new materialization or build. The Dagster can understand and report on freshness of your assets. For example, you can say that a machine learning model is considered out of date if it doesn't factor in any training data from the past 24 hours. If so, it should either try alerting its consumers about its staleness or try rebuilding itself. And auto materialization policies are a way to automatically do that. So I can automatically update your data products when the data it depends on changes. So with regards to data quality, users should be able to trust the data is accurate and true. We've already talked about how asset checks are great for this in general. Like they let you test your data and surface those results to you and your consumers. And it's nice to be able to just like quickly add alerts with Dagster Cloud of it, or just out of the box Dagster open source. And because owners and other asset metadata are programmatically defined, you can either add test coverage for them or query your Dagster instance to make sure these properties are configured before ever pushing to production. All the functionality to do everything in the slide is available to you in regular Dagster open source. But Dagster Cloud makes it really easy to set up alerts on what we just talked about. If certain asset checks fail or if freshness marks an asset as overdue, you can notify a Slack channel, an individual, a Microsoft Team channel, or an entire team of people on what's happening. All right, let's see what this looks like in real life, though. We'll look at a demo of a very simple and contrived data mesh implemented in Dagster and showcase the value of what I've been talking about. All right, so we flop over to VS Code over here. We'll see that each Python module in this project maps to a hypothetical domain, such as marketing or sales or that core underlying data platform. And then in the data platform module, we have this additional set of utilities that other teams can use and just import them into their own modules. These functions aren't exclusive to Dagster, but is just some code that emulates what a data platform might do. There are some helper functions that are typically helpful when it comes to exploring a data mesh, such as for the producing domain to be able to publish data assets. And on the flip side of that, for the consuming domain to understand what data products exist and a mechanism for being able to fetch them. Then if we look at one specific domain like sales, we can see how a domain can use a data product. Well, we can just import that utility, you just call it like any other Python function, and then depend on over here. As we would with any other asset that you might define in Dagster, you just define dependencies with either like the asset key or the asset itself, or just a string, which is what this all maps to in get data products. That little catalog in the back that contains and understands what those data products are. And that's all it takes to depend on an asset from another code location. You just have to know what it's named. Then let's see what this all looks like in the Dagster UI. Let's look at the deployment tab first. And here we can see that the platform, the data platform, the sales, and the marketing code locations are all there in presence. Then we can look at the asset graph. Here we can see where I grabbed the source, where I grabbed that screenshot from earlier. We'll see that the data platform team does their own data modeling for that core data, bronze, silver, gold architecture. And then the downstream data products or data assets can use that data, in which we can see here. And we'll observe that, yeah, this data, these assets that are made in the sales code location depend on data from that exists in the gold layer of the data platform. And we can see that, okay, well, this is the last time it ran, and here are the data quality checks associated with those gold layer assets, and that they've all passed them recently. We also have metadata associated with it, such as its row count, its standard deviation, so on and so forth. And if we want to look at the full end-to-end lineage of an individual asset, we can just go ahead and click on the lineage and see how it goes from end to end, and not only shows us the data products that it might be using, but all upstream source data that it could depend on, which could be pointing to yet another domain. Now let's make a change that will actually like break that marketing code location. So let's go ahead, pull up any file in here, and let's just type in anything that will break Python. Then we flip, did I save? Yes, I did. Flip over to that, and let's just redeploy all of our code locations again. Give it a second. Cool. And it failed. And we know exactly why it failed, because I'm the one who put that garbage text there. But the great thing is, most of the deployment is still fine. The only part that broke was that marketing code location. Sales is still up. The data platform is still up. And if we go to the asset lineage, we can still materialize and run and use our sales and data platform, data products and assets, however we see fit. And the sales and data platform teams are none the wiser that the marketing team has broken anything at all, because they're completely isolated and independent from each other. And if we just, and let's say like the marketing team goes back and fixes whatever bug they made, they can just go ahead and redeploy that one individual code location. And then everything works all fine and dandy as it did before. Cool. And that is it for that demo. So yes, as a summary of everything, data mesh is an organizational and technical paradigm for making high quality data by domain experts. It focuses on those 4 principles that we talked about earlier, and Dagster's framework of building blocks can help enable the technical aspects of data mesh. yeah, if you're interested, if you like this content and you just want to hear more about it, feel free to join us in our Slack to have more conversations about this stuff. If you like seeing some of the features that we used about from Dagster Cloud, feel free to sign up for an account. You get a 30-day free trial with it. Also, feel free to sign up for our newsletter. We have a really big launch event coming out later this month, which I hinted a little bit of the functionality for that you might have picked up from. So if you're interested in signing up for it, either go to the Dagster website or sign up for our newsletter to get a reminder for it. And we just crossed 10,000 stars on GitHub. If you would like to be part of the party for the next 10,000 stars, please feel to visit the Dagster.io GitHub repository and give it another star. All right, that is kind of it for the presentation. Any questions?
Awesome. Thanks so much, Tim. We have actually gotten a few questions in the chat. We'll see if we get some more, but I'm going to go ahead and read them out. There was one question here from Rahul, and and a lot of people put an emoji on it, so it looks to be like a good one. He said, can you show how you are configuring asset level alerts?
Do I have a Dagster Cloud instance that I can just pull up publicly right now?
If not showing it, maybe we can just discuss it.
Yeah. So there is in Dagster Cloud. So for asset level alerts, you can either programmatically do it yourself in Dagster OSS by just triggering alerts, or by like using a sensor or something. We have a handful of like out of the box sensors that will listen to asset materializations or whatever, and you can send alerts based on that. But if you were in Dagster Cloud, there is a whole separate tab over here called alerts, and it shows that little like all it shows is a list of different there's a list of different alert policies that you might have. And if you want to make a new one, you can just click new, and it pops up as a little modal, and you can pick what kind of alert it is. And this is all done via the UI and just works out of the box with Dagster Cloud. You can target individual assets, groups of assets, entire code locations, and you can trigger and set the granularity of like, okay, well, why should it be alerted? Because a asset failed to materialize, or it failed its asset checks, or if it's just considered out of date. Yeah, we also have docs on this, which we can send a link to later on, which I think has better screenshots in this.
And then Chris asked, can alerts be deployed or defined alongside asset code? And I do believe that is a feature where you can have configuration files for these alerts.
Yeah, it's called, Colton's right, in which with Dagster Cloud, in addition to doing or working with this in the UI, you can also export and import YAML files to say or to define alert policies. So yeah, you can keep those stored in version control and like deploy that out as like with every new Dagster deploy or whatever. So
Yep.
yes, your all of your alerts that come with Dagster Cloud can be locked in code and in version controlled.
Yep. And as Tim mentioned, for the OSS users, this is also possible through sensors and selecting asset groups or specific assets to have a sensor on if it fails, and then you can send an alert that way. And that would be a more programmatic way of doing it. Let's see. Chris also asked, is there a way to query the metadata for data assets, such as the lineage, code locations, data checks, etc.?
Yeah. Okay, so that is so the answer is yes. The way you can get it is by this magic context argument that you get with all of your assets. So if you want to actually wait, so is there a way to query the metadata for assets? So yeah, if you want to do this externally of Dagster, we have a whole GraphQL library and everything, or GraphQL endpoint that you can query and get all that information from. But if you want to, like, let's say, get it from an existing what's it called asset, like while you're trying to materialize another asset, yeah, this context argument has a whole lot that you might want to be able to access. Like for example, you can get everything like the asset key or the asset definition itself, and then grab any like properties you might want to get from that, such as execution type, freshness policies, whatever like certain properties are set. Then if you just want to understand like how it's running and like what the context is, you also have access to the run that is currently trying to materialize that asset. And then you can get access to properties like, well, what other assets are being selected by it? However, how many other assets are being run with it? So yes, you get a whole suite of different um, properties that you can get from the context argument. And this little stub function I wrote earlier helps exemplify some of it, in which like if you want to get Dagster is a very like event driven system in which you can just query and fetch events about other asset materializations as you like. This is a pattern that I like doing, in which we can just grab the latest materialization event of any arbitrary asset and then be able to act on it and just understand like, okay, when we get the metadata from it, such as the location, which in my case is mapped to the file name of where the asset was saved. If I pull up that demo over there, go into an asset, we can see that it's mapped to like this file path. So yes, there are like you with the context argument, you can access literally anything you possibly need about uh, assets, the assets metadata, to run, or historical materializations.
Awesome. All right, we have some questions over in the Q&A form. Andrea asked, what happens if we import an asset from a different team by importing version X and then the team releases a new version Y? How would that be executed by Dagster and shown in the interface?
So out of the
Sorry.
box, sorry, Colton, you had an answer?
No, go ahead.
Okay. So out of the box, Dagster doesn't maintain data or what's it called? Doesn't version or access specific different versions of assets or data products. However, like this can be written, I've seen it incorporated in a different way, in which Dagster keeps track of what we call like a data version, which is essentially just like a hash of what the code looks like. And then you can like upstream or downstream as consumers, you can say like, okay, well, if it doesn't match the data version of the previous materialization, hold off on it and just wait and like don't materialize anything until I do otherwise. Or that you can write additional abstractions on top of that to do your own behavior, such as automatically upgrade or alert or so on and so forth. Dagster is a really flexible framework that like its goal isn't to like solve everything for you, but help give you the building blocks in order to do what you need to do in order to solve those problems.
Great, thanks, Tim. And then we have a chain of questions from Bruce. We can go through these. So number one, what languages are supported? Only Python? Uh, Dagster itself is written in Python, and typically when you're defining your DAGs and everything, you would use Python. But we do have the concept of Dagster pipes, and we actually have a demo in our repo of using Rust. So you can easily interface with other languages, though predominantly you will be using Python. Yeah. He asked, can metrics be accessed from Grafana in real time? Tim, do you have an answer to that one?
So in real time, no ish. It depends. Like this is one of the situations in which like it is on the user code to be able to push out those metrics out to Grafana in the first place. And so it can be done. The definition as to like the latency and how much real timeness you want will depend on like the implementation of the code yourself.
Yeah, and we do have users who are emitting events to Datadog and things like that. So um, really anything is possible. It just depends on the how you implement it. There's a lot of flexibility in how you can use Dagster. The next question was, is there automated testing support? Uh,
We can answer that question if you mind clarifying what you mean by automated testing, because that'll be very helpful and we can give you like a more like tactile answer about it.
yeah, I mean, in
Yeah, I mean,
general, oh, sorry, go ahead.
yeah, go ahead.
No, please clarify, sorry.
Oh yeah, I mean, I see that you made some code changes. It's deployed. It's directly to production. I'm just trying to figure out what type of automated testing can
Hmm.
we do? Can we do like a record replay, right? Do we have to set up our own data examples on every step there to do any type of automated testing? just trying to figure out what type of support is there, right?
Yeah, I mean, we've definitely done like a lot of unit testing. Given that most of Dagster is just like Python code, you can very easily use PyTest and set up a test suite around your pipelines. Dagster also supports branch deployments, which are really powerful for ensuring that your pipelines work. So say you open a pull request with a change, it can automatically spool up a separate deployment of Dagster with those changes in that branch. And typically you would use like a sandbox database, and you can ensure your code functions correctly there. People also have done end-to-end testing. I haven't been involved too much with that. I don't know if you want to elaborate, Tim, but it is definitely possible to set up a pretty thorough test suite around Dagster pipelines. Well, hopefully that answers your question. Oh yeah, and your next question was, is there dev test environment support? So totally, yeah. One of the benefits of Dagster is the ability to run things locally and have dev like UAT and prod deployments. And a lot of that is enabled through having Python code that can be unit tested. Typically, devs will work locally on their machines, potentially connect to like a dev database or something like that using environment variables, depending on what you want to connect to. But that's definitely supported. The next question was, what is the difference between Dagster open source and Dagster cloud? Tim, do you want to talk about that a little bit?
Yeah, sure. So Dagster open source is a open source Python framework. It has all the core functionality that you need in order to run Dagster and have an orchestrator. Um, Assets, asset checks, auto materialization policies, most of the things I just talked about, or like today, code locations, those are all in the open source product, and those all will work 100%. Dagster Cloud has additional functionality that really accommodates for how do you deploy and use Dagster at scale, and how do you like run a data organization with a strong orchestrator. This gives you functionality like branch deployments to see like the blast radius of like what happens when you make a change, or insights which empowers people to understand, let's say, like how many snowflake credits or Databricks units does it cost to make an asset over time? Is it changing over time? And other stuff like that. If you are interested in hearing more about Dagster Cloud, we have a really big event coming up that's really dedicated towards it. I'm trying not to spoil too much of it. Fraser would have my head for it. I saw him come off camera for a very brief second with an axe. But yeah, so yes. So if you're interested in hearing more about the benefits of Dagster Cloud, either reach out to us, or definitely like tune in for our launch event later this month.
Awesome. Yeah, and then our final question, I think we'll end it on this one. Bruce also asked, can asset checks be shared across domains?
Yeah. Asset checks are just Python functions, so you can just import them and use them as you see fit. Like it's a fairly generic Dagster concept, so you can build a generic asset check that does things like check for nullness, and then import that across different modules and apply those to all your domains.
Awesome. Well, thank you so much, everyone, for attending. If you have any other questions, feel free to hop on the Dagster Slack or GitHub discussions, and we're happy to talk more. But for now, that's all we have. Thanks again.
Well, take care.